Our project topic is a deep learning based social distance monitoring framework for COVID 19. Group members are Zakia Khan, roll number 22, Shagufa Syed, roll number 42, Taneem Sheikh, roll number 57. The coronavirus, which caused COVID 19, originated in the city of Wuhan, China. After only a few months, the virus was hit by the global outbreak in the year 2020. To control the disease, World Health Organization recommended that countries should practice social distancing. From this video, we understood practicing social distancing is one of the most important ways we can protect ourselves and each other. Social distancing means limiting our interactions and avoiding close contact with each other. The more we stay apart, the less chance the virus spread. Problem statement. Images from many parts of the country, especially major cities, are proof that social distancing norms are being violated. While cases are already rising faster than before in India, floating social distancing norms would worsen the situation. To control this, government have taken preventive steps to monitor social distancing, but it requires large number of manpower at every public places. Proposed system. We propose a three-stage model including people detection, tracking, and interdistance estimation as a total solution for social distance monitoring and analysis. Our project is designed for monitoring social distancing at many public places. Input is in the form of video which is collected from any of the 24 administrative wards under Brihan Mumbai Municipal Corporation. In each ward, we select three places and capture short videos at peak hours and calculate violation percentage. Based on the output, we analyze that in which area there is more violation and more patrolling is required. This will help to use manpower efficiently and analyze which ward is more prone to spread of COVID-19.
In this project, that is a deep learning based social distance detection, we have used various algorithms. So the first one is object detection. For object detection, we have used Yolo, that is you only look once. Yolo is widely used object detection framework. It can detect over 9,000 different classes and can process approximately 45 frames per second. From the schematic architecture, it can be seen that feature learning is performed using convolutional layers. It performed detection at three separate scales. The architecture used a single stage network for the entire input frame to predict the bounding box and class probability of detected objects. During human identification, the input frame is divided into a region of S by S grid, that is grid cells. These cells are related to bounding box estimation and class probabilities. After detecting people in video frames, the next step is to track the object. For object tracking, we are using OpenCV library. This algorithm is called as centroid tracking as it relies on Euclidean distance between existing object centroid and the new object centroid between subsequent frames in the video. Here, the first step is to accept bounding box coordinates from an object detector and use them to compute the centroids. We will assign unique ID to each person. Then we need to compute the Euclidean distance between each pair of original centroids and new centroids. Lastly, the closed pair distance centroids are detected as same person. After object tracking, we need to measure the distance. It applies to approximate the distance between the centroid of each rectangle drawn. Let's say this is an object, and from here we are capturing the pictures. We are using f is equals to p into d the whole divided by w, this formula, where f is the focal length, p is the pixel, d is the distance, and w is the width of an object. And hence we are calculating the minimum distance between the object by using this formula, w into f the whole divided by p. So let's move on to the workflow diagram of our project. First, video sequence are given as input. Then we will split the data into training dataset and testing dataset. We will deploy pre-trained Yolo for human detection and computing their bounding box centroid information. In addition, a transfer learning method is applied. We are using COCO dataset for training. After detecting bounding boxes, we are computing pairwise distance between each centroid. We have set minimum distance as 50 pixel. If distance is less than 50 pixel, then we will add them in violet set, otherwise we will add them in non-violet set. The bounding box color is initialized as green. The information is checked in the violation set. If the current index exists in the violation set, the color is updated to red, otherwise remain the same, green. Furthermore, the centroid tracking algorithm is used to track the detected people in the video sequence. At the output, the model displays information about the total number of social distancing violations, percentage of violations, and we will analyzing them. So let us start the working of our project. Here I have created and activated virtual environment. So let's write the command here. Here I am giving pedestrian.mp4 as input and fetching the output in output.avi file. Pedestrian.mp4 file is present in the same folder. So let's run this command. It will take some time to process the video. It starts executing and percentage of violation is showing on the display output. The video is also downloaded in the current folder. We can abort the session using Q. As you can see, output file is downloaded here. You can see the downloaded file. We are also fetching all the highest percentage in one notepad file in order to calculate the average and analyzing them using some data analysis tools. Thank you.
Analysis of social distance detector model. We have collected violation percentage data in notepad file and performed data virtualization which represent comparison of two wards. From this we analyze the graph which shows different places versus peak hours where it shows the percentage of violation of social distancing. As we can see the hospital surrounding area which shows less percentage of infection spread as compared to highly crowded Nagpada junction during peak hours. From the graph we can see that most of the people are not taking social distancing seriously, due to which there are high chances of increase in the cases, hence more awareness is required. Conclusion. We proposed a deep neural network-based social distance detector model to detect and track static and dynamic people in public places in order to monitor social distancing metrics in COVID-19 era and beyond. To automate the process of monitoring the social distancing via object detection and tracking approaches, where each individual is identified with the help of bounding boxes. The generated bounding boxes aid in identifying the clusters or group of people satisfying the closeness property, computed with the help of pairwise vectorized approach. By minimizing the close physical contact among people, we can reduce the chances of catching the virus and spreading it across the community. Future scope. The outcome of this research is directly applicable for a wider community of researchers. not only in computer vision, AI, and health sectors, but also in other industrial applications, including pedestrian detection for driver assistance systems, autonomous vehicle, anomaly behavior, detection in public and crowd, surveillance security system, action recognition in sports, shopping centers, public places, and generally any application that human detection falls in the center of attention. Next is automatic data collection, visualization, and report generation of social distancing. And the last one is real-time social distance detection.